a weapon made of plywood, aluminum tubes, and hot glue. It costs less than $400 to build, and it just erased the last safe zone on the Ukrainian battlefield. 18 miles behind the front line, Ukrainian soldiers used to drive with their headlights on. That's over now. Since the start of Russia's full-scale invasion, both sides have fought a brutal drone war, mostly with small first-person view quadcopters that cost a few $100s each. But these FPV drones have a problem. Their range maxes out at around 10 miles. Beyond that, you need artillery, and between those two ranges, 10 to 30 miles, there was a gap, a dead zone. Too far for drones, too close for long-range fires. For 2 years, that middle zone was where Ukraine moved its supplies, rotated its troops, and ran its logistics with relative safety. In the spring of 2024, Russia closed that gap with plywood. And what Russia built with plywood, Ukraine eventually captured, stripped down to its bolts, and rebuilt into something with twice the range and none of the flaws. But the real story isn't just the drone. It's the moment Ukrainian engineers cracked open a captured Molniya and found hot glue holding critical components together, glue that melts at 86 degrees Fahrenheit. That discovery set off a chain of events that's now reshaping how this entire war is fought. We'll get to that. But first, let's talk about the weapon that started it all. Picture this. Somewhere behind Russian lines in the Kherson region, 3 soldiers crouch in a concealed position. Each one carries a backpack. Between the 3 of them, they're holding 10 separate components. They unpack them onto the dirt, 2 aluminum tubes, each about 5 feet long, plywood plates laser cut to precise dimensions, a set of foil-covered wing panels, 3 servos, 1 electric motor, a battery, and a warhead. Assembly takes 2 to 4 hours. No specialized tools, no factory, no runway. When they're done, what sits on the ground in front of them looks like a homemade model airplane, a fixed-wing drone with a 5-foot wingspan weighing about 22 pounds. The body isn't even a fuselage. It's just 2 aluminum tubes running parallel held together by plywood cross pieces. The wings are plywood ribs covered in plastic film. The tail is the same plywood and foil. This is the Molniya, Russian for lightning, and it is by every measure one of the crudest weapons flying over Ukraine right now. It's also one of the most dangerous. The soldiers loaded onto a pneumatic catapult, a small portable launcher that fires the drone into the air with compressed gas. No runway needed, no vehicle needed. 3 men, 3 backpacks, and in under 4 hours, they have a guided weapon ready to fly. The Molniya's electric motor spins up. The catapult fires. The drone launches at a steep angle, climbs to altitude, and levels off. Its operator, wearing FPV goggles back at the launch site, now sees what the drone sees: a live camera feed streaming back over a radio link. The drone cruises at about 50 miles per hour, maximum range up to 20 miles for the original Molniya one. Flight time around 40 minutes. 40 minutes and 20 miles might not sound impressive next to a Shahed or a Lancet, but here's the thing, the Molniya isn't competing with those. It's filling a gap that nothing else was filling, for under 400 euros in materials. Reports from the front indicate the total component cost, including electronics and batteries, doesn't even reach that figure. That's less than the price of a decent laptop, and the warhead options are brutal for something this cheap. Early Molniyas carried improvised charges made from hand grenades and RPG warheads, 3 to 5 kilograms of explosives. Later variants escalated. The Molniya 2, which appeared in late 2024, carries up to 10 kilograms. Some have been documented carrying a full TM62 anti-tank mine. That's a weapon designed to destroy a main battle tank strapped to something made of plywood. The Molniya 1 had a single nose-mounted motor. The Molniya 2 upgraded to 2 motors in nacelles under the wings, wrapped in a new plastic fairing. Range pushed out to nearly 40 miles. Speed increased to around 75 miles per hour. And then Russia started iterating even further, adding fiber-optic control cables that make the drone completely immune to electronic jamming, and machine vision guidance systems that allow the drone to track and hit targets even after losing its radio link. And that fiber-optic variant, it's not just a technical upgrade, it fundamentally broke one of Ukraine's most effective defenses. We'll explain how and what Ukraine did about it later in this video. The impact on the battlefield was immediate. The commander of the Antares Unmanned Systems Battalion, part of Ukraine's 4th National Guard Brigade, described the moment his unit realized the rules had changed. His call sign is Samir. He recalled a day when his troops were operating 18 to 20 kilometers behind what they considered a stable front line. At that distance, they felt safe. They drove with their headlights on. They moved in the open. Then a Molniya hit. That formula, the idea that 20 kilometers kilometers back meant safety was dead, and it wasn't a one-time event. Russian units began deploying Molniyas systematically in volume. By mid-2025, analysts from the Moscow Times documented Molniya strikes reaching past 30 kilometers in the Kherson region, pushing into areas near the border of the Mykolaiv region, deep into what had been Ukraine's logistics backbone. The kill zone, the area around the front line where nothing moves without risking a drone strike, had been expanding for months as FPV drones improved. But the Molniya pushed it further. According to NPR reporting from March 2026, the kill zone now extends roughly 25 kilometers, about 15 miles from the front line. Ukrainian military officials estimate that up to 80% of frontline are now caused by FPV drones. The Molniya extended that lethality into the mid-range band that had previously been a corridor for survival. And here's what makes it a systemic problem, not just a tactical one. The Molniya is built from materials available in any hardware store. Plywood, aluminum tubing, consumer-grade electronics sourced from China. There's no exotic supply chain, no precision manufacturing. Russian forces can build these in field workshops in volume with minimal training. It's not a weapon that can be sanctioned out of existence. But Russia's greatest advantage with the Molniya also became its greatest vulnerability, because when you build something simple enough for anyone to make, anyone can make it. Ukrainian forces began recovering crashed and intact Molniyas from the battlefield. Some were shot down, some malfunctioned, some were captured in overrun positions, and Ukrainian engineers did exactly what you'd expect engineers to do in a war of survival. They took them apart, piece by piece, screw by screw. What they found inside didn't just give them a blueprint, it gave them a roadmap for how to make it better. And by the fall of 2025, Ukraine had scaled its own version so fast that more than 60 Ukrainian military units were already using it in combat. But before that happened, one engineer in a small town in western Ukraine changed everything. His name is Vladimir Musur from Broshny Vosad, and his story is worth telling. Musur received a captured Molniya. He disassembled it in what was essentially a workshop setting, not a defense lab, not a military R&D facility. He mapped every component, recreated the design, and then he started training others to do the same with the explicit goal of transferring the knowledge to the military. Meanwhile, a volunteer group called Ostani Capitalists, the Last Capitalists, launched a crowdfunding campaign. Their target, $300,000. Their promise, 350 combat-ready drones. That puts the unit cost at roughly $857, barely twice the material cost of the Russian original, but now including launch systems and control modules. The result is the Blyskavka, Ukrainian for lightning, the same meaning as Molniya, just in a different language. And here's where it gets interesting. The CEO of Viri Drone, Alexei Babenko, told Ukrainska Pravda what his engineers found when they cracked open the Russian originals. At the start, Russia had many rough solutions. Some components were simply held together with hot glue, the kind you'd use for a school art project. That hot glue begins to melt at around 30 degrees Celsius. That's 86 degrees Fahrenheit. On a warm summer day on the Ukrainian steppe, the structural integrity of the drone would start to degrade just sitting in the sun. Launching the Molniya also required several people working in precise synchronization. If anyone made a mistake in the timing, the drone simply would not launch. The Ukrainians fixed both problems. They replaced the hot glued components with 3D printed parts engineered to maintain shape and load consistency regardless of temperature. They redesigned the launch sequence so it could be executed with fewer personnel and less margin for human error. Then they improved the specs. The original Molniya one had a range of 30 to 35 kilometers. The Blyskavka in its Viri drone configuration reaches 80 kilometers, roughly 50 miles. Flight time, 60 minutes. Maximum speed, 160 kilometers per hour, about 100 miles an hour. Payload capacity up to 9 kilograms, and the cost 35,000 Ukrainian hryvnias. That's approximately 810 US dollars. The innovation chain from captured Russian drone to mass-produced Ukrainian weapon moved through a pipeline that no traditional military procurement system could match. Individual engineer to volunteer fundraising network to private defense startup to the Brave One national defense tech marketplace to 60 plus military units in combat. By January 2026, Ukrainska Pravda Pravda reported that the Blyskavka was being used regularly and at scale against Russian equipment and fortifications. Before we go deeper, this is the war bill, and we bring you the full picture of what's actually happening on the battlefield, not just the headlines. If you haven't subscribed yet, now is the time, because what comes next is where this story goes from a single drone to an entirely new way of fighting a war. Remember the fiber-optic Molniya variant we mentioned earlier? Here's why it matters. Ukraine's most effective frontline defense against Russian drones has been electronic warfare jamming systems that disrupt the radio link between a drone and its operator. When the signal breaks, the drone crashes or flies off course. For standard FPV drones, this works. For standard Molniyas, this works, but fiber-optic drones don't use radio. They trail a hair-thin optical cable behind them as they fly, transmitting video and receiving commands through light pulses in glass. No radio signal means nothing to jam. Ukraine's multi-billion-dollar investment in electronic warfare becomes irrelevant against a plywood drone dragging a spool of fishing line-thin cable. Russia began fielding fiber-optic FPV drones in the spring of 2024 and quickly adapted the technology for Molniya variants. These drones can't be jammed. They can't be detected by passive radio sensors. They can fly low, land on a road, and wait idle, silent, invisible until a vehicle passes. Then they lift off and strike. Ukraine's commander-in-chief Alexander Syrsky publicly acknowledged that Russia currently holds the advantage in the fiber-optic drone race, both in quantity and range of application. That's a remarkable admission from the side that has consistently led in drone innovation, but Ukraine's response has been characteristically fast and layered. Ukraine didn't rely on a single solution. Instead, it built a defense-in-depth architecture against the Molniya threat, combining high-tech and low-tech in ways that would look bizarre to any conventional military planner. Layer 1 electronic warfare, still effective against the majority of Molniyas that use standard radio links. Ukrainian EW units jam control frequencies, forcing drones to crash or lose targeting. Layer 2 fire teams, specialized anti-drone squads using interceptor drones, including FPV drones armed with shotgun-style payloads to physically shoot down incoming Molniyas in flight. Ukraine's Azov-linked air defense FPV units documented the destruction of 6 Molniya drones over Donetsk in a single engagement using this method. Layer 3 physical barriers. This is where it gets striking. Over the city of Izium in eastern Ukraine, white nylon nets now stretch over roads, sidewalks, and entire city blocks. Cars drive through tunnels of netting. Pedestrians walk under canopies of mesh. On the Izium-Sloviansk highway, a net tunnel stretches for 40 kilometers, about 25 miles, protecting one of Ukraine's critical logistics arteries. The Ukrainian government has announced plans to install roughly 4,000 kilometers, 2,500 miles of drone netting along frontline roads by the end of 2026. Layer 4 airborne electronic attack. In an extraordinary development documented in June 2025, a Ukrainian FPV drone appears to have disabled a Russian Molniya 2 in flight using an onboard jamming system. The Ukrainian drone approached the Molniya, which then lost control and crashed a non-contact interception. Similar incidents have been recorded repeatedly since March 2025. No single layer is sufficient. Together, they form a system that degrades the Molniya's effectiveness without requiring any single silver bullet. In September 2025, Ukraine hosted Defense Tech Valley Europe's largest dual-use technology and investment summit in Lviv. Over 5,000 participants from more than 50 countries attended. This wasn't a trade show. It was a demonstration of the innovation pipeline that turned a captured plywood drone into a mass-produced weapon in under a year. Viri Drone showcased its full product line at the event. The Blyskavka Strike drone, a new tactical reconnaissance UAV called Sokil with a range of 130 kilometers and a price tag of $3,000 to $5,000, a mothership drone called Veresin, designed to carry FPV drones deep behind enemy lines, and its first tracked unmanned ground vehicle, the Jankoi, equipped with Starlink satellite communications and a payload capacity of over 500 kilograms. That last item, the ground drone, points to something much bigger. In late 2025, Ukraine's 3rd Assault Brigade deployed a single unmanned ground vehicle, a DevDroid TW 12.7, armed with a heavy machine gun to hold a frontline position. The robot drove to a contested sector each day, watched for Russian movements, and delivered suppressive fire. Each evening, it withdrew to a covered position for maintenance and reloading. It did this for 45 consecutive days. No infantry present, 0 Ukrainian casualties. Russian forces were, in the words of the unit commander, constantly suppressed by the fire of the TW-12.7 droid and failed to advance through the sector. Mykola Zinkevich of Ukraine's 3rd Army Corps described the concept in 5 words: robots do not bleed. That phrase isn't just a slogan, it's a doctrine. Ukraine faces a grinding manpower crisis as the war approaches its 4th year. The Ministry of Defense reported that it surpassed all UGV supply targets in 2025. Ukrainian industry delivered 15,000 unmanned ground vehicles to frontline units that year, up from 2,000 in 2024. By November 2025, the BBC reported that up to 90% of all supplies to Ukrainian frontline positions around Pokrovsk were being delivered by ground drones. In July 2025, Ukraine officially established the world's first UGV battalion within the K2 regiment. The chain of logic runs like this. The Molniya extended the kill zone to 25 kilometers. That kill zone made human logistics suicidal. Suicidal logistics forced Ukraine to adopt ground drones. Ground drones proved they could do more than haul supplies they could fight, and a weapon that started as a piece of Russian plywood accelerated Ukraine's transformation into the first army in history where robots hold the line. But here's the part of this story that almost nobody is talking about. The innovation cycle isn't one-directional. Russia is watching everything Ukraine does with the Blyskavka and the UGVs, just as Ukraine watched what Russia did with the Molniya. Russian forces have already begun developing their own ground drones designed to carry and launch FPV drones. Concepts like the Roy Swarm model and the Cultivator combat platform suggest Moscow is exploring offensive UGV capabilities. The real race isn't about who has the best drone, it's about who can complete the cycle. Fastest capture, reverse engineer, improve, mass produce, deploy, and then do it again when the other side adapts. Ukraine's current edge is speed. An engineer in a small town disassembles a captured weapon. A volunteer group crowdfunds the first batch. A startup professionalizes the design. A government marketplace distributes it, and within months 60 units are using it in combat. Russia has numbers industrial base and Chinese components. Ukraine has speed adaptability and a decentralized innovation network that no top-down military bureaucracy can replicate. The question is how long that speed advantage holds. And that's the question this war keeps asking. Not who has the biggest army, not who has the most expensive weapons, but who learns faster, who copies faster, who fixes the flaws the other side missed and gets the improved version into a soldier's hands before the enemy adapts again. Right now, Ukraine is winning that race. Plywood drones that cost 400 euros are being countered by 3D printed drones that cost $800, flying under tunnels of fishing nets stretched over highways alongside armed robots holding trenches for 6 weeks without a single human life at risk. This is what modern war looks like, and it's only getting started, and it's about to get a whole lot more complicated because the fiber-optic drones that we talked about both sides are now pushing their range past 50 kilometers, and Ukraine may have just found a way to burn those cables out of the sky with lasers. Find out more in our next video. Or if you want to understand how Ukraine built the world's first ground drone battalion from scratch and why NATO is scrambling to learn from it, check out this video right here. And if you found this breakdown valuable, make sure you're subscribed to the War Bill to stay ahead of the curve on how technology